guys? I hope you're doing good today. Today we're doing 6.4, which is moving on through our circle unit in Unit 6, and we're going to be talking about something called secant lines, okay? So the first thing I like to talk about is what am I saying whenever I actually mean a secant line. So what I mean by secant line is whenever you're given a circle, and then on that circle you have a line that is actually going to go through that circle and touch it at two exact points. What I mean is if I have a line, it's going to go through this circle and it's going to touch that circle at exactly 1 and 2 points. So basically a secant line means it's going to go through the circle and touch at 2 points. And so we're going to take this and we're going to actually apply it to some examples, and it's going to help us to solve some problems here in the future. Okay. Thing here. So it says on the first one, on the first definition here, it says the product of the length of the secant segment and its external segment is equal to the product of the other secant segment and its external segment from the same point outside the circle. So right now, this definition, whenever you read it, can be a little bit confusing at first. What I'm going to do is I'm actually going to draw a circle and I'm going to explain further in detail. So what I'm going to do, and this is what you're actually going to draw inside that picture section, okay? So right now, I'm going to have two lines, basically. Let me go ahead and get my colors here. I'm going to do this one blue here. So I'm going to have a secant line going through this circle, okay? And then I'm going to do this one in red. And then I'm going to have another secant line going through the circle, but they're going to intersect at the same point outside the circle. So let me go ahead and draw that point so we can see it out here. So there goes my point right there. Okay, and so right now, basically, I'm going to go ahead and label this. So I'm going to call this part right here A. I'm going to call this part right here B. I'm going to call this part right here C. And I'm going to call this point right here D. And I'm going to color code this so we can see it. So again, let's go ahead and read that. It says the product of the length of the secant segment and its external segment. So right now, just to clarify, let's go ahead and look at that blue line. So let me go ahead and do this in blue real quick. So let's do that blue line. So right now what that means is I'm going to take the entire segment. So that means from the point outside the circle and the point touching both of the circles. So that entire segment of the blue one is A and B. So what I'm going to do is I'm going to take A, I'm going to add B, and that entire segment. And what it means is I'm going to multiply the segment external. So outside the circle. So that means the point touching the circle here and the point from here is going to be segment A. So I'm going to add the whole segment together, and then I'm going to multiply the segment outside the circle, okay? And then that is going to be equal to the same thing of the other one. So I'm going to do that one red. So what that means is I'm going to take C and D, I'm going to add those together, and then I have to multiply the segment outside of the circle. So you have outside the parentheses. So the segment outside the circle of the red is going to be segment C. So I have to multiply this. So right now, ladies and gentlemen, this is going to be the equation that you're going to use to solve a situation to end up solving what that piece is. Okay. So what I just drew here, you're going to stick that into the picture segment of that first part there. Okay. So let's move on to the second definition here. Next definition here. So it says here, the measure of the angle formed by two secants intersecting a point outside the circle is half the difference of the measures of the intercepted arcs. So let's go ahead and draw that picture real quick, and I'm going to explain to you what that means. So right now, go ahead and draw a circle inside that equation there. And again, I'm going to have two lines that are going to be drawn here. That's going to create two secant lines, and they're going to touch outside that circle. So I'm going to do them in two different colors again. So I'm going to have my blue line going outside the circle, and I'm going to go have, oh, I was going to change the color, but we'll just do two blue, it's fine. And they're touching at exactly 1 point outside that circle. And so what that means is now I'm going to have my angle here. So this one angle right here that's being created, I'm actually going to take the difference of the two intercepted arcs. So what that means is where these two circles are touching right here and right here, it's creating an intercepted arc right here, this arc right here. And it's also touching right here and right here. And so I need to take that intercepted arc as well. So what it says in the definition is to find this red angle over here, I have to find the difference of those and take 1/2 of it. So I'm going to call this A, this arc over here. I'm going to call this B, and then this red guy over here, I'm going to call that C. So in order for me to find C here, C is going to be equal to, I have to take that larger arc. You see A right there is the larger arc. So I have to do the larger arc minus the smaller arc. I'm going to subtract those, and then I have to take 1/2 of that. So basically, if A was 12 and B was 6, I would do 12 minus 6, which would be 6. Then I would take half of it, and that would end up giving me C. So right now, ladies and gentlemen, this is going to be what you're going to put inside that picture section right there, and you're going to end up using that. Okay? So let's take what we just looked at. We're going to apply it to our example 1, 2, and 3, and then we'll move on and let me know if you have any questions. Well, so let's move over to example number 1. All right, guys, so let's go and look at example number 1. So it says, what is the measure of angle BFE? So right now we're going from B to F to E right there. And so we're actually trying to find that angle. So earlier on that last definition, I know that I have to take the difference of the two intercepted arcs, subtract them, and then take 1/2 of it to get that angle. So basically what that means is I'm going to take angle BFE. So to find angle BFE, I have to take 1/2, and if you look, I have intercepted arc from C to D and intercepted arc from B to E. So I need to take the bigger one minus the smaller one. So the bigger one is going to be 97, and my smaller one is going to be 15. Okay, so right now, 97 minus 15. So 97 minus 15 is going to give me 82. So I'm going to take 1/2 of 82. And when I take 1/2 of 82, divide that by 2, that's going to give me 41. So that means BFE is going to be 41 degrees. So again, the main thing you have to look at is that arc CD is bigger than B and E. So I have to do the bigger one minus the smaller one, because if I do it the other way, it's going to end up making a negative, so I can't have that happen. Okay, so let's jump over to example number 2. So on example number 2, it looks like I'm going to end up finding that side X there. So I learned earlier, I'm going to add the entire segment together and then multiply the product of what's outside the circle, and then that's going to be equal to the same thing on the other segment. Okay, so let's go and look at that. So right now, this is what I'm going to write. I'm going to add the entire segment together. So that's going to be 7 plus X, right? And then I'm going to take what's outside the circle, which is going to be X, and put it here, okay? I'm going to set that equal to the same thing on the other one. So I have to take what the entire segment's going to be. So I'm going to do 29 plus 5. And then what's outside the circle is going to go on the outside. So right now, ladies and gentlemen, I have to solve for X. So let's go ahead and simplify what's on the right side over here. So first thing, I'm going to do 29 plus 5, which is going to be 34. And then I'm going to actually multiply that times 5. So whenever I do all that, that's going to end up giving me 170 on the right side over here. And so now I have to simplify by distributing my X over here. So you should get 7X plus X squared is going to equal 170. Now what's going to happen is we're going to have a quadratic right here now. So actually what's going to happen is I have to end up subtracting 170 on both sides here, and it's going to end up creating a quadratic here. So 170 and then minus 170, so it's going to cancel over here. So what's going to happen is I'm actually going to erase this so I can have it bigger here, is it's actually going to end up turning into a quadratic here. So let's go and look at it. So right now I'm going to have X squared plus 7X minus 170. So what I'm going to actually have to do is I'm actually have to solve this quadratic, something that you learned in algebra. So I have to figure out what two numbers are going to multiply together to equal negative 170, and they're going to add together to equal 7 as well. So just to skip to it, 17 and 10 are going to be those numbers, but 10 is going to be my negative, because 17 times negative 10 gives me negative 170, and then 17 minus 10 would give me 7. So what's going to happen is this is going to split up into X plus 17 and then X minus 10. And so if I actually set both of these equal to 0, so X plus 17 equals 0, and x minus 10 equals 0, I'm going to actually solve for x. So on the left side over here, I would subtract 17 on both sides. So that would give me negative 17. And on the right side, I would add 10 on both sides, which would give me 10. And so right here, I'm actually dealing in length. So that means my answer can't be negative because everything in length is positive values, right? So my answer can't be this negative 17 over here. So that means my final answer is going to be 10 because I solved that quadratic there. Not all of these problems are going to end up like this, but if you got into a situation where you got your variable on the outside like that, that's how you would end up solving it by using the quadratic there, okay? So let's jump over to example number 3. All right, now lastly, let's look at example number 3. So it says, what is the length of arc BC? So that means I'm actually going to end up finding this middle guy right here. So arc BC, okay? So I know that I have two secant lines meeting outside of the circle. So my formula is going to be the smaller circle, or the smaller arc, which is going to be 32. And I'm going to set that equal to 1/2 the measure of the bigger arc minus the smaller arc, which that's what I'm trying to find. So I'm going to represent that as x. So I'm going to take this bigger arc, which is 145, and I'm going to subtract x right here, okay? So right now I'm going to go and get rid of the 1/2 by multiplying by 2 on both sides, okay? So 2 times 32 is going to give you 64, and then the 2 is actually going to get rid of that 1/2 there. So I'm going to get 145 minus x, okay? And so now I'm going to end up subtracting 145 on both sides. So 64 minus 145, 64 minus 145 is going to give you negative 81. And on the right side, I'm going to be left with negative x. I can't have a negative variable, so I'm literally just going to flip the sides on both of them. So that means x is going to be equal to 81. So that means this value, BC, is going to be equal to 81 degrees. So all I did was I used the formula that I learned earlier, was I took that bigger arc and subtracted the smaller arc, took 1/2 of it, and that gives me the smaller one. So then that means this is going to end up being the formula I'm going to use in this situation. So I hope this helps. I hope you guys can take this and apply it to some of your skill check. If you have any questions, please feel free to reach out. Good luck, guys.